Hello everyone, welcome back to Calculus. And this time, for real, we are going to study the derivatives of trigonometric functions. And somewhat I really want to tell you, because of the situation, we are not going through all the details to derive the formulas. I'm just going to present the formulas to you. And you need the requirement for now, it is you only need to know the formulas. And actually, they turn out to be relatively simple and easy to remember. So sine and the cosine. Let's start from sine and the cosine. Okay. Derivative of sine, it tends to be cosine. And as you may expect, somewhat cosine does go back to sine. But anyway, you may want to remember this clearly. Derivative of cosine tends to be negative sine. Okay, negative sine. And usually for my class, I would suggest you really know sine and cosine very well for trigonometric functions. And then what would happen to tangent? Well, the book did list derivative of tangent as a formula, but I would say if you know trigonometric functions very well, and if you know calculus very well, and this time it's worth to take a look. We can derive the formula, the derivative for tangent by ourselves. So let's take a look how we handle the derivative of tangent. Remember, tangent is the quotient of sine and cosine, right? So the derivative of tangent turns out to be the derivative of quotient of sine and cosine. I guess I said a quotient a couple times. So I'm saying be very sensitive in a calculus class. When we say there is a quotient, usually we meant we need to consider the quotient rule. So the quotient rule, it is right here. It is covered in the previous section, derivative quotient. Okay, I use U and V for both quotient and the product. And I suppose for now, you should have remembered how the formula looks like. And also, I do have the formula copy and pasted here. If not, take a look. If you cannot remember, if you are still not familiar with the formula, take a look at now. And I hope from this point on, you are going to know the product rule and the quotient rule very well. So this is the quotient rule. And I'm taking U as the numerator, V as the denominator, and then I calculate the U prime and the V prime. And then I made the arrangement, this long part. Okay, it is according to the arrangement, the formula for the quotient rule. And then I look at the terms in the numerator. Cosine times cosine. I think the cosine is squared, right? And then minus sine, and there's another minus here. Actually, I think I need to make a correction. I believe this should be minus sine because that is really the derivative of denominator, derivative of cosine, which is negative sine. So I'm saying we are seeing two minus sign, which tend to be plus. Sine times sine, that's sine squared. Still, it may look pretty big for the numerator part, but I hope you recognize, you must recognize this thing. It's the Pythagorean identity, right? Cosine squared plus sine squared equals 1. So it just turned to be 1 over cosine squared. And again, about the way to consider the notation for trigonometric functions, cosine squared really means cosine x with parentheses squared. So 1 over cosine squared, it really means 1 over cosine x with parentheses squared. And this time we said that there are many trigonometric identities. One group of identities is called as reciprocal identity. So the reciprocal of cosine, that's the secant, right? So it tends to be secant squared of x. Derivative of tangent, it is secant squared of x. So for this part, actually, I just introduced 3 new rules for derivatives of trigonometric functions, derivative of sine and cosine and tangent. How about before we take a break, let's take a quick look. Somewhat, kind of older kind of example. I say a classical example in calculus. Find out the equation of the tangent line. Certainly this time, it doesn't involve with trigonometric functions. So it is to find the equation of the tangent line to y equals cosine x at x equals 2 pi over 3. Find the equation of the tangent line. Okay. So usually the way to handle the equation of line, we use the point slope form. So I have the point slope form right here. And I suppose you do understand x naught, y naught, they form a given ordered pair, a given point. So the given point, clearly it is at x equal to pi over 3. Accordingly, y naught would be the function value. So cosine of 2 pi over 3. Cosine of 2 pi over 3, remember, we did calculate those values. Well, in the other part we reviewed a moment ago. Okay, cosine of 2 pi over 3, which tends to be negative. So I got the value negative 1/2 here. This forms that given ordered pair x naught, y naught. And then we have one more quantity to figure out, slope. Remember, slope is a derivative. So I just write m equals derivative. And also, maybe this is the first time I use notation. I have a bar of the derivative notation, then x equals a number using the subscript form, which really means the derivative at this specific value, and which is the slope of the tangent at this given point. Okay, so the derivative of cosine is negative sine. The given point is 2 pi over 3, so the slope should be negative sine of 2 pi over 3. And again, we calculated sine of 2 pi over 3, okay, which is square root of 3 over 2. But still the minus stays. And therefore, the equation of the tangent line, y minus y naught, y minus negative 1/2 equals the slope right here times x minus x naught. And also in this case, I would say if you want, you can consider the slope-intercept form. But anyway, we do consider point-slope form as a standard for the line. So you could just leave the answer like that. Or really I should have said, well, two minus signs, minus negative quantity just tend to be plus. So I'm saying you should just leave the answer like that. Really, I'm not bothering about the slope-intercept form at all. Keep the answer just like this. It's very clear. It does show me if this problem is on the test or for the homework. It shows me clearly how you get all the numbers, and you do understand the form, the point slope of a form of a line, and you do understand how you get the slope from the derivative. And by the way, speaking of the homework, I really believe this is one of the homework assignment. So if needed, do take a look again, and it is on my notes too. Hey, thank you for watching. See you next time.